Okay, so this is going to be a quick little demo of how to bias the Volcano 20-watt amplifier. And you can see there's some test points built into the chassis here. The black is the common, and the two grays are specific to the two 6v6 power tubes here. And they are side by side. So the left gray test point tests the left power tube, and the right gray test point tests the right power tube. And there is a bias adjustment pot right here. Let's see. So right next to the bias test points, there is a pot and a potentiometer. That's for adjusting the bias on the amp. So here's the left tube test point, the right tube test point, and the common test point. This is set up so you can just test it with your multimeter. And so that's what I'm going to do right here, just to show you how to set the bias with using your multimeter. Now, the amp's currently out of its casing just because I'm finishing up and making some changes to the case, but this is the case. It's a Celestion G12 EVH speaker, and this is a 20-watt amp with 3 Mullard CV4004 preamp tubes. These are just like heavy-duty 12AX7s, and 2 Mullard 6v6 GTs, and that's about a 20-watt amplifier. It's all point-to-point. I guess I could give you a quick little peek inside here. Let's take a look. Move the stuff out of the way, and I'll show you kind of what the guts look like. This is my, let's see, I guess I shouldn't twist this, right? Because it's going to look funny on the video. But so it's a point-to-point amp, and so there's no turret board, no eyelet board, no PCB. All the components are just mounted directly to one another inside the amplifier chassis. The blue can caps on the inside, those are filter caps for the B+ line, as is the black cap here on the outside. They're all 50-50 caps. The inside ones are by F&T, and the exterior one here is JJ. They're all 500 volt 50-50 filter caps. So we have a nice solid B+ high voltage going to the circuit. All right, B+ starts out around 400 volts and gets knocked down along the way. I'm not going to go into the whole circuit here, but just to show you how we're going to bias the amp. So I've got the IEC plug here. I'm going to plug it into my Variac. The Variac set at exactly 120 volts AC coming from the wall. It could be 123, 124. I've got this set to exactly 120. You don't need to do that. You could just bias the amp having it plugged into the wall, and that's fine. Voltages will change depending on the venue where you're playing. But before we plug in the amp here, we do want to make sure that we've got the speaker connected. And this amp has a speak-on connector. It's a locking speaker connector. And so you want to make sure you have your speaker connected. And there we go. Before you use the amp or turn it on. All right, that's just generally always true. If you don't have the speaker connected or some type of load, you could use a resistor for testing, but for most guitar players, you just want to have the speaker connected for amp service techs, you could use something like this. This is an 8 ohm resistor, and I just have it connected to a 1/4-inch jack. Obviously that doesn't work in this amp because it doesn't have a 1/4-inch jack. It's got the speak-on connector. But this is for more typical amps. And you can use that instead of a speaker. But for guitar players, you want to just have your speaker connected. All right, so got that connected, nice and solid. We're going to plug in the amp. And off to the races here. Let's see. There, good. All right, so this is just a little variac. I use it to form capacitors normally. You don't need to use a variac to do this. I'm just plugging the amp in that way because it's convenient on my desk here. All right, and I'm biasing this amp right now because I had it previously biased with Mesa Boogie tubes installed. I had these Mesa 6v6 GTA SDR17s installed here previously, and you know, each pair of tubes that you use, whether they're matched or not, you need to set the bias. It's a fixed bias, adjustable bias, fixed bias amplifier. So you do need to adjust this pot. All right, and the way we adjust that pot is we have our little screwdriver here somewhere. Where's our screwdriver? We can use sort of any screwdriver. It doesn't have to be too special. And you can just insert the screwdriver down into this pot hole. And if you twist it, it'll eventually slide into a screwdriver slot. Oh, there we go. Okay, now once you have that done, you can twist it counterclockwise or clockwise. Counterclockwise increases millivolts, clockwise decreases millivolts. Now I'm not going to do that just yet because we need to measure the bias first of the amp. Okay, so we've got the amp plugged in. We've got a 120 volt line coming in. We've got the speaker installed. Let's turn on the amp. I'm going to turn down all our volume knobs. Basically the master, the gain, and the volume down. You can also turn the variac knob. This is a variac knob, I call it. It's not really the same as this variac. This is the type of variac that Eddie Van Halen used with his Marshall stack to reduce the voltage a little bit coming into the amplifier itself. This is a feature of the Volcano amp that's I call the variac, and it adjusts the internal low voltage AC signal. So it does vary the AC, but it's not the AC coming into the amp. It's the low voltage signal. All right, so that is intended to kind of replicate the variac effect from that Eddie Van Halen used on his Marshall amp. All right, so now we've got the amp turned on. Tubes have had a little bit of time to warm up. I'm just going to turn off this light so we can see. Okay, we've got filament power going into the power tubes. We've got filament power, you can see, to the preamp tubes. I don't know if you can see that or not, but a nice little glow there. And what we need to do now is bias the amp so that there is 24 millivolts of bias current, of idle current going through there. And the way we're going to do that is we're going to turn our multimeter to the millivolts setting. Okay. We're going to take our probes and we're going to insert the black probe into the common test point. Okay, so it's just sitting there in the common test point. You don't have to shove it in, don't push it in, just, set it in there gently. No problem, just so it's sitting inside the test point there. Okay, and then we're going to test each tube one at a time. Okay, so the first tube we're going to test here is this left-hand tube, power tube. I'm just going to gently set the multimeter probe into that test point, and I'm going to read my millivolts here. You can see that it's 33.7. That's too high. You can see for this amplifier we want to bias at 24 millivolts. Okay, so I'm going to insert my screwdriver into the bias adjustment pot, and I'm going to just gently twist it until it drops into the slot. There's a screwdriver slot down in there. There it goes. And I'm going to turn it, and you're going to see how very slowly, I'm just turning it clockwise, and that's going to reduce the millivolts going into these tubes. Okay, I want it to be right around 24. I'm actually turning it clockwise. Okay, now I went a little too far. We're at about 23.2. Come back a little bit, 24.6. Gonna try and adjust it till I get right around 24. It doesn't have to be exact. 24.1, 24.3. Even if it's anywhere between 23 and 25 is actually fine. 24, let's see. Oh, going down a little too much here. It's pretty sensitive, so small movements in the screwdriver. All right, you can see I'm just barely moving the screwdriver, and it's making a big adjustment on the millivolts here. 2383. There, okay, so 24.2. That's pretty good. All right, so now I'm going to take my screwdriver out. So now this left power tube is getting about 24.2 millivolts of idle current. All right, now I'm going to move my red probe over to the right-hand test point, and now I'm measuring the idle current of the second power tube, this right-hand power tube. Okay, and I see that it's at 25.46, so 25.5 idle current on the right tube, and 24 even on the left power tube. I guess I can make a slight adjustment. 25 is fine. Let me just swap that over. So I'm bringing my test point back over to the right tube. And then, whoop, there, let's get that thing set in there. Better. Okay. So now you don't even have to hold them. When the amp is installed in the cabinet, this will be just horizontal the way it is right now, and you can just set your probes in there if they fit with the speaker magnet. Now you may want to use test probes that are slightly shorter if you have some, because they'll fit underneath the speaker magnet a little bit better. But so I'm just going to adjust this a little bit more. Take my screwdriver, inserting it in the slot there until it drops down. I just feel it, drop in. Kind of twist it until it drops in. You can tell when it does that. Sometimes it takes a second to get it in there. Let's see. There we go. Okay. So we got 2544. Bring that down to, say, 24.9. Okay, so we're going to try and split 24 across the tube. So we're going to try and have it kind of even. Okay, now the left tube is 23.4. So we're 0.6 millivolts low on the left tube and 0.9 millivolts high on the right tube. And that's fine. Okay, so anywhere between 23 and 25, even 22 and 26. But we do want to be somewhere bracketing 24 millivolts. Okay, and the reason you set your meter to millivolts is the amp is designed with some 1 ohm high precision resistors on these test points, and so that makes a direct conversion from milliamps to millivolts on your multimeter here. Okay, so that's how we bias the amp. You can do this with, you don't need to remove the chassis from the amplifier to do this procedure. I just happen to have it out of there. So it's designed to be able to adjust the idle current simply and easily without using a tool like external socket adapters like this VHT bias meter, which I actually kind of like. This is a nice meter. It also has test points that you can plug your DMM into if you want, but you don't even need one. You can just use the little gauges that it's got. So you can bias using this type of a product as well. However, these actually won't work in this Volcano amplifier because they raise the tubes up too much and the chassis won't fit in the amplifier when the power tubes are that high. So this is much more convenient. We've got about 23 to 25 and we are good. So we're going to take these out. If we installed a different set of power tubes like these Mesa tubes or these new old stock 6v6 GTs, we would just want to make sure we rebias the amp so that the amp has about 24 millivolts showing on our multimeter. That equates to 24 milliamps of idle current in the amp, and that's about a 70% dissipation rate. All right, cool. So hopefully this is helpful.